This is an update of the commands that we executed before. So let's now proceed to the next. We'll have F for fill. So F will have the syntax of F, and then there is range list. Now by range list, we mean the starting address and then the end address, and followed by the list. So again, your range address would contain starting address, end address, and now we'll be proceeding to the execution of the code. So let me just enlarge this. Okay, so we have your DOS box. Okay, to start with, to execute the F command, we have to activate the debug. So F, this is our parameter, and we have to indicate our starting address. So say our starting address is 100. So we have 100, there's a space, and then our end address will be at 12F. Then our list, this would contain our memory space, thus will have the text buffer. So this is enclosed in the string because we have this is enclosed in a single quotation because we are indicating here the string. So press enter. Then to display the result, D 100 to 12F. So we have the complete set of code. Let's try to check what would be the result of this command. Okay, so now we have indicated here the starting address. So our starting address is 100 and onwards. So accordingly, we have that string buffer. So F fill command that stores a block of consecutive memory locations with the same data. So what is that the same data that we refer to? So the one that we indicated here as a list, and that is buffer. So we have the text fill, so buffer, repeating this on a consecutive memory location. So ito siya. And if you are to check on the result, so it overrides the previous location, the bits, and that it is considering the output BUFFER, and these are the bits equivalent to its ASCII code. So if we may check on random letters, say we have the text buffer, so we have B, so it's 62. What else do we have on buffer? We have letter F, 66. So there should be 62 and 66. So in here we have 62, 66. That is a proof that this result is consistent with the expected list of ASCII codes. Okay, so we have F for fill, we have the starting address, the end address, and this is the list. Okay, so let me now highlight F as we are done executing this. Okay, next we'll have unassemble. So for unassemble, you have to type in the code indicating on the hyphen letter U and the range of value. So by the range of the value, you have to consider the starting address and the ending address. Okay, let's proceed. So again, for U, which is unassemble, you have to identify the starting address and the ending address. So let's proceed. U, and with that we have indicated our code for unassemble, and we have to indicate now our starting address. So let our starting address be at 126 up to 12F. Press enter. So as you can see, this is our starting address, and then our ending address is at 12F. What is U, or unassemble command, is all about? This command converts machine code instructions to their equivalent assembly language source statement. So these are the equivalent assembly source statements. So the execution of this command causes the starting memory location, and the source statements, and this time it comes with both the machine code and assembler forms instruction. So the memory data to be displayed on the screen are considered on its machine code and assembler forms of the instruction. As we executed the command for unassemble U, I have already highlighted this. So these are the list of codes that we have executed, the one highlighted in yellow. So let's now proceed to the debug command I for port. So the syntax is, you have to identify I with its port. So input output port is also considered in this case. So let us proceed now. So you have your DOS box, and let's enable debug. So we'll explore on I for port. So there is an execution for how to read the hours and minutes based on our computer's real-time clock. To do this, let me check first my computer's real-time clock. So 7:02 a.m. So let's check. We have first to identify the format, and how to check the hours. So we have O for output, and then to check the hours we have the code 70 space 04, enter. Okay, we can now check on our output. The port for that is 71. Press enter. So it's 7 a.m. So as we have to validate it from here, this is our hour, 7 a.m. So we have 03 for the minutes. Now let us try to check if we are going to check on that port for the number of minutes. So we have to identify first our format to check the minutes. So this time we have 7002. So this is the format for us to check the minutes. Press enter, and this time to check on the minutes, our input on the port 71. Press enter. So let us check. So we have checked a while ago that it's 703. So the port that we have indicated for 71, and with this format, is that we're able to identify the real time clock of this computer. So it's 703. Okay, so let me quit this so that the next code, the next execution will be demonstrated. So since we have executed let me now highlight this. Okay, in the previous example, we have demonstrated the results for the port, and that we were able to demonstrate the combination of both the input and the output port. So let me highlight input and output port. Okay, we have the port byte here. So you just check on the videos, the previous video, on how it was integrated. So let's now proceed to the next command. We have the compare. So the compare command will have the syntax C and then range address. Now your range address contains the starting address, the ending address, and the destination address. Again, so on the range, you have to consider the starting address, the ending address, and the destination address. So let's execute the code. First, we have the debug, and then the syntax for this, C and its range. So first, we have the starting address. Say the starting address will be at 100, and our ending address will be at 105. Let's make this a bit short, and then comparing this on a and we'll put it on the destination address to 0. Press enter, check on the result. So we have our starting address at 100. This is our ending address at 105. What is the C or compare command is all about? So this compares the contents of the two blocks. It compares the contents of these two blocks. So it determine if they are not the same. So ang tinitingnan natin if they are not the same. So if both blocks contain the same information, then no data are displayed. Each time unequal elements are found, the address and the contents of that byte in both blocks are displayed. So in this example, it is unequal elements. So then the address and the contents of that byte in both are displayed. So let's try to check what will happen if there are same information. So as we said, it is expected that if there are the same information, no data are displayed. So let us set the range. So C, then we have to identify a starting address, like let's have 10A to 10F. Okay, that let's check on 20. Press enter. So we have 10A to F. Still, we have unequal. So let's try to check another unequal value. So C, we have still 10A to 10F. Okay, data natin ng konti. So we'll have this 110. Okay, the destination address. Let's try to check. So it has to be A, B, C, D, F. Ganun pa rin. Lahat sila may difference. So, shorter. C, 10A to 10F. Then this time, range 200. Okay, so this time it is expected that the range should be 10A, 10B, 10C, 10D, and 10E, 10F. So it has supposed to display those results just like what we have here, only that as it compares the result, so the blocks contain the same information. So on 10A, there's no display. 10B, no display. 10C, wala rin. 0, 1, 0, D, wala. And starting with this range, which is also within the range of 10A and 10F, there is that unequal element. So ito lang yung nakita nilang unequal element. So if it is unequal, and as the comparison is executed, it will display the result. So ano yung result na yun? The address and the contents, of that byte in both blocks are now displayed. Okay?